This is Algebra 2, Lesson 10-4, Simplify Rational Expressions, the hard version. Today's date is Monday, March 30th, 2020. Today, all you're doing is you're taking notes on this lesson. You don't even need to touch the homework. You can take a preview if you want, but the homework we're going to be working on tomorrow. So tomorrow we'll have no video and is only the homework. Today's objective is to simplify rational expressions that require advanced ninja star with higher degree terms. When I say higher degree terms, I'm thinking something aside from quadratic. So x to the power of 3, 4, 5, something like that. All right, so our procedure is still the same. It has not changed. I did simplify it to make it a little bit easier. Step 1 is to factor out the greatest common factor, like always. And every single one of the problems you're having for the homework, the numerator and denominator will always have a greatest common factor other than 1, at least as far as I've seen. I guess the homework for tomorrow, right? And then step 2 is ninja star. Step number 2 is to set the denominator equal to 0, and then that will give you your undefined values. When it says in your problems, list all values that make the expression undefined, that's what it means. Set the denominator equal to 0 before you cancel out. And then step number 3 is to finally cancel them out. And you're only allowed to cross off things that are being multiplied. Let's go. Example number 1. Simplify and express in expanded form. This guy is notoriously I shouldn't say super difficult, but it messes up students every single year. Expanded form is not factored form. Factored form means they have parentheses, but if I have like 2 out front, I need to distribute that 2 onto the inside. There should be no more multiplication happening. It is purely expanded form. All right, so here we go. The greatest common factor for the numerator. In terms of the coefficients 2, 1, and 21, those are all co-prime, so I can't factor out anything there, but I can factor out an x. This is x to the power 4, 3, and 2, the smallest being the 2. So the greatest common factor of those 3 is x squared. What's left over is a 2x squared minus x minus 21. All right, what about the denominator? Again, first step is factor out the greatest common factor. For the coefficients 12, 38, and 14, the greatest common factor here looks to be 2. Can I do 4? No, 4 doesn't go into 14, so 2 is the greatest common factor for the coefficients. And in terms of the exponents, it goes 3, 2, and then this is a hidden 1. 1 is the lowest power, so that's the greatest common factor there, 2x. When I factor out a 2x, I'm dividing 12x to the power 3 divided by 2x, and that's going to be 6x, and then I subtract 3 minus this 1 here, that's going to be 2. So 6x squared minus, that's going to be 19x minus 7. All right, so all I've done so far is greatest common factor. Now I'm going to do ninja star. I need to do it for this and this, the numerator and denominator. So this is where I'm going to do scratch work off to the side because we don't have very much room left over. So this is the numerator. So again, I'm going to multiply 2 and negative 21 for the top. That's going to be negative 42, and this negative 1 in the bottom, negative 1. All right, what times what is 42? Let's think. 1 and 42 doesn't work. 2 and 21 doesn't get to 1. 3 and what is it going to be? 3 and 14, I think. That doesn't work. What about 4? No, 5, 6. Oh, 6 and 7. 6 and 7. Yeah, that'll work. Okay, so 6 times 7. Let's make that a negative 7. And I'm not doing advanced ninja star. Shoot, advanced ninja star. Yeah, 6 and negative 7 work down here. But I should have been putting 2 and then x in this number divided by 2. So it's going to be 2x in the top left and top right. Then backwards, whatever. And then I need to reduce these fractions. The right-hand fraction can't be reduced, but this left-hand fraction can be reduced to x over 3. And this new factored form, I leave this greatest common factor out here. So I'm going to rewrite this x squared, and now it's going to be x plus 3. X plus 3 and 2x minus 7. 2x minus 7. The numerator is completely factored now. Okay, the denominator, I'm going to go ahead and rewrite the 2x, that's the greatest common factor, and then I'm going to do ninja star on this. So let's do some scratch work. Advanced ninja star, again, it should be a 6x in the top left and top right. Let's not forget that step this time. 6 times negative 7 is negative 42, and I'm going to bring that negative 19 down here. Oh, interesting that they both have negative 42 for the tops. That's a coincidence in this case. It doesn't always happen that way. What times what is 42? 1 and 42. No. 2 and 21. Oh, yeah, 2 and 21 will work. Okay, so 2 and 21. The negative has to go with the 21 because the bigger number should be negative. And reduce these. 6x and 2 turns into 3x and 1, 6x and 21. That goes to, divide the top and bottom by 3, so 2x. I know I'm kind of running out of room here. And then 21 divided by 3 is negative 7. And there they are, so 3x plus 1. So 3x plus 1, and 2x minus 7. 2x minus 7. Whew, that was step 1, and it is by far, in my opinion, the hardest step of doing these problems. Now I'm going to do step 2. Set the denominator equals 0 to find undefined values. So right now I'm working on the bad values. Let's find the bad values that make it undefined, which means I'm setting this entire denominator equal to 0, which means 2x could be equal to 0. It could mean that 3x plus 1 is equal to 0, and it could mean that this 2x minus 7 is equal to 0. This is the zero product property that I'm invoking right here, where every single one of these terms could be equal to 0. And this is, I'm kind of taking a shortcut. Technically, I should be writing this line exactly equal to 0, and I skipped a step and said, well, knowing that this could be 0, this could be 0, or this could be 0. So that's the step that I'm kind of skipping here. And then from there, I'm solving. Divide both sides by 2, x could be 0. That's a bad value. So if x is 0, that is going to make this expression, this rational expression, undefined. Subtract 1 from both sides, so I get negative 1 on the right-hand side of the equal sign is equal to 3x, and therefore x is equal to negative 1/3. Add 7 to both sides, you get 2x is equal to 7, and therefore x is equal to 7/2, or if you prefer, 3.5. All right, those are my bad values. Let me go ahead and circle my bad values. Okay, so I've done list all values that make the expression undefined, check, but I have not simplified yet. That's the main thing. So now I'm on to step number 3, which is to cancel out if they're being multiplied. These 3 terms right here are all being multiplied. Same thing for the bottom. So what looks the same in the numerator and denominator? It looks like I have a 2x minus 7, 2x minus 7, and I will repeat, I cannot just rewrite x squared times x plus 3. In the old homework, that would be okay, but we need to do expanded form. So unfortunately, that means we have to distribute this x squared back inside in order to get the correct answer. If I rewrite this in Khan Academy, it will give me an incorrect answer. So my final answer is x to the power of 3 plus 3x squared in the numerator. Ooh, I missed one other thing that we can cross out before I do that. Does anyone see it? I have an x here and x squared here. It's really x to the power of 1 here. So I have 1x I'm crossing off and 1x I'm crossing off. So there were 2 x's here. I crossed one of them off to leave me with 1 x's. So my thing that I'm going to distribute is just the x into the x plus 3. I realize that might be a confusing step, but really think of this x squared as x times x, and in the denominator I have an x. I'm crossing them off. I'm left with 1x. So this is going to be an x squared after distributing this x into this x plus 3 plus 3x in the numerator, and in the denominator I'm going to have this 6x plus 2. And just checking through this, nothing here can be factored out, of course, so that's my final answer. Done with example number 1. On to example number 2, and I will repeat myself again. All we're doing today is notes, so if you understand the notes completely, you're done. If you want to work on the homework early, then you won't have any homework to do tomorrow, or maybe just do half the homework tomorrow. Go ahead and do the greatest common factor for the numerator. Looks like it's going to be 2. Obviously, I can't factor out any c out of this because there's no c to factor out. So when I factor out a 2, I'm left with 1 minus 16c squared. When I factor out the greatest common factor for the denominator, 3 goes into both 3 and 12, so 3. And then what's the smallest power? It looks like it's c to the power 5. So 3c to the power 5 is the greatest common factor between these two terms. When I factor that out, I'm dividing 3c to the power 5 divided by 3c to the power 5, and I get 1. And then divide this 12c to the power 6 by 3c to the power 5. 12 divided by 3 is 4. So copy down the sign here. Plus 4. And 6 minus 5 is 1. So c. Oh, that's kind of a nice little factor. Then I'm going to... I can't do anything else with the denominator. Like, this is not... you can't really do a advanced ninja star with this. This is just a linear term. There's no higher power here. Once it's 1, then I'm done. 1, then done. Kind of rhymes. All right. This one can be advanced ninja starred, or if it is a difference of squares, so you can use a shortcut on it. I always like using advanced ninja star. It's the one tool that I can just keep using over and over if I've mastered it. I'm going to kind of reverse it a little bit to make it make more sense, and then I'll make sure that I'm keeping track of the minus sign here. Really, I know it's going to be a conjugate pair, so I'm comfortable doing this, but technically I should be writing this as negative. I'm thinking that this might mess us up, but let's try it. I'm really writing negative 16c squared plus 0c plus 1. This is exactly the same as this right here. So if I do that, I know that I always said make sure that your leading coefficient is a positive, because otherwise it'll mess us up. Hopefully we'll be okay. We'll check our work at the very end. Let's plug in our numbers. So I multiply this number and this number to put in the very top. That's going to be negative 16. I write my 16c, and the middle term is 0. What times what is 16? That also adds to 0. Well, 4 and negative 4. Reducing these gives us, divided by 4, it's going to have 4c and 1, and 4c and negative 1. And that's exactly what it's going to be. I'm going to go ahead and flip them back again. So normally you'd think, okay, well, if it looks like 4c plus 1, 4c plus 1, this is incorrect, by the way, and 4c minus 1, that would be equal to it, but that's not quite true. We have to flip it back again. Remember how we switched these two at the very beginning in order to get to this advanced ninja star? I have to switch them back again. I realize that sounds like a confusing step, but what I'm really saying here is we have to account for the fact that this is a negative 16c squared. Check it out. If I multiply positive 4c by positive 4c, I will get a positive 16c squared. The only way to get this to be the correct answer is by switching these. The way that I do that is I list this as 1 minus, or 1 plus 4c, and 1 minus 4c. Again, if you just use a shortcut, it will jump directly there. Again, the shortcut is take the square root of the first, the square root of the last, and if it's a difference of squares, it's a pair of conjugates. So there's that. And don't forget that 2 that's still out front, the greatest common factor. This 2 right here. All right, for that denominator, I can't do anything. I'm just going to go ahead and rewrite him. So I have a 3c to the power of 5 times quantity of 1 plus 4c. And lo and behold, we can cross things out, but don't do that yet, because first I need to find the bad values. So this is me finding the bad values, the values that make this rational expression undefined. I'm going to set both of these two things that are being multiplied, this 3c to the power of 5 and this 1 plus 4c, both of these are going to be set equal to 0. So I have 3c to the power of 5 is equal to 0, and I have this 1 plus 4c is equal to 0. All right, so solving both of these, divide both sides by 3, and I get c to the power of 5 is equal to 0. And once I take the fifth root of both sides, c is equal to 0. It's pretty straightforward from there. Subtract 1 from both sides, 4c is equal to negative 1, divide by 4, and c is equal to negative 1/4, or if you prefer decimals, negative 0.25. So I'm going to circle my bad values. That's one bad value, that's the other bad value. There are only two bad values. And finally, step 3, I'm going to go ahead and cross things out. So crossing things out, see a 1 plus 4c, a 1 plus 4c, and I'm basically done. The only thing that I have to be careful of is it needs to be an expanded form, which means I need to distribute this 2 into the 1 minus 4c. So let me do that really quickly. This is going to be equal to, I don't know if I have enough room here. It's going to be 2 minus 8c in the numerator, and in the denominator I'm going to have a 3c to the power of 5. And that's my final simplified answer. That's example 2. We have one final example, and then we are done with the notes, done with today. Example number 3. Here we go. In the numerator, factor out the greatest common factor. So greatest common factor is 3 for the coefficients. 3 goes into 3, it goes into 9, and it goes into 12. Therefore, it goes into 120. I can't factor out any y's because 120 doesn't have any y in it. So 3 is the greatest common factor of these 3 terms. When I factor out that 3, I'm left with a y to the power of 8. Ooh, that's big. Plus 3y to the power of 4 minus, okay, 120 divided by 3. It's 12 divided by 3, which is 4. Add the 0 again, so 4d. And what about the denominator? The denominator of the greatest common factor looks like 2 for the coefficients, because 2 goes into 2 and 16. And I choose the smallest power between y squared and y to the power of 6, and that's y squared. When I factor out that 2y squared, I'm left with, okay, well, 2 divided by 2 is 1, so no more coefficient. 6 minus this 2 is y to the power of 4. And then if I divide 16 by 2, I get 8. Copy down the sign, of course, so it's going to be plus 8. And then 2 minus 2, they're gone, so there's no y, just like that. All right, so I can't really factor this y to the power 4 plus 8 anymore. The reason I know that is just from experience. But generally speaking, unless you have a minus sign in between two terms, you're not going to be able to factor them. They might be a difference of squares, but there's no difference. It's a sum of, this isn't even a square. So there's nothing I can really do there. The numerator, however, this looks familiar. If this was just I want to compare it to y to the power of 2 plus 3y minus 40. These two look very similar. I know how to do this one. This is Advanced Ninja Star. The only thing I'll have to change is I know that my factors are going to be y to the power of 4 instead of just y for my leading terms for my factored form. What do I mean by that? Let's go ahead and just set up Advanced Ninja Star for this thing right here. By the way, this yellow stuff, it's not related to this blue problem aside from it looks similar to this yellow form, and I know exactly how to deal with that yellow form. I'm still dealing with the blue. I'm still dealing with our original problem. So multiply the coefficient here by the coefficient, or by the constant term here. So 1 times negative 40 is negative 40. The bottom is going to be that 3, that middle term, and then this is where I change things up. I choose y to the power of 4 and y to the power of 4. Why did I do that? Well, first the leading coefficient was 1, so this is a 1 that's invisible, and then I took this number and I divided by 2, or if you prefer thinking of it, I'm kind of just stealing that middle variable and power, y to the power of 4. All right, so now my Advanced Ninja Star is set up, and I'm just ready to flow from here. So what times what is 40? Let's go through all the factors. 1 and 40, no way to get 3. 2 and 20, no way to get 3. 4 and 10, no. 5 and 8. Oh yeah, 5 and 8 will somehow get 3. So on our list, 5 and 8. Which one has to be negative? So this 5 is negative because the bigger number should be positive. All right, and then I can't reduce anything because there's no coefficient here, so these are simplified, which means I'm ready to go ahead and rewrite my numerator. I still have that 3, the greatest common factor, and then I'm going to go ahead and write these terms. So I have this y to the power of 4 minus 5, and that y to the power of 4 plus 8. In the denominator, I have 2y to the power of 2 times the quantity of y to the power of 4 plus 8. I just copied the denominator down. Again, I didn't change anything. I'm done factoring. I can't do anything else. This might look like a difference of squares, but 5 is not a square. So how do we do this? Step 2, I'm going to set this denominator equal to 0, which means my bad values down here. That's a bad D. There it is. My bad values are going to be when 2y squared is equal to 0 and when y to the power of 4 plus 8 is equal to 0. Solving both of these, divide both sides by 2 and I get y squared is equal to 0. Take the square root of both sides and y is equal to plus or minus 0, or just 0. Over here we have, let's subtract 8, so y to the power of 4 is equal to negative 8. And then I take the 4th root of negative 8, and that's, you can't do that. So y is equal to the 4th root of negative 8, and that is not a real answer. And I realize that this is now not the perfect problem. This is a pretty good problem because there's things that cancel out. But it's not a good problem because this should have been a positive number. If I change this to next year, I'll change this to y minus 8 and y minus 8 because that would make this a nice number. Whenever I take an even index root of a negative number, it's going to be a complex number, which I didn't want to have you guys deal with. This is still mathematically correct. You don't have to worry about it. If that ever does magically happen in Khan Academy, which it shouldn't, then you just fully ignore it. If I take the even index of a negative answer for the radical, just don't worry about it. Ignore it. So yeah, I'll just leave that crossed off. There's only one bad value. It's 0. So I found one bad value, and step 3 is go ahead and simplify by crossing things out. And there's nothing else I can cross off. So go ahead and distribute this 3, and I'm done. So the final answer, I'll do this in red, is 3y to the power of 4 minus 15. All of this divided by 2y to the power of 2. Final answer, and box it. All right, that concludes Algebra 2 Notes 10-4. Again, we don't have any homework tonight. That homework will officially be assigned tomorrow. I will leave it up on Khan Academy if you want to take a look at it. But again, all we're doing tomorrow is you're going to meet and then just say hello and then start working on the homework based on these notes. I'll see you guys tomorrow. Thanks.